mean, construction of an electrochemical cell. Like I was telling you all that what are electrochemical cells? The apparatus or the cells in which the electrochemical reactions are taking place in such a way that there is interconversion of electrical energy into chemical energy and vice versa. Okay, the cells in which electrical energy is getting converted to chemical energy is nothing but electrolytic cell, and the other one in which a spontaneous chemical reaction is giving electrical energy is nothing but a galvanic or voltaic cell. Both are said to be electrochemical cells. The best example, like the way we have discussed yesterday, that the best example is our lithium ion batteries, which we are using in our mobiles, laptops, etc. Okay, it is nothing but the best example of an electrochemical cell. Okay, and it is both electrolytic cell and galvanic or voltaic cell. How would you say that? When you are using the mobile is getting discharged. In this case, when the mobile is undergoing discharging, that is, you are using the mobile for your purpose, the battery is acting as a galvanic or voltaic cell in which a spontaneous chemical reaction is giving electrical energy. That's the reason why we are able to use the battery. Okay, and when you are keeping the mobile for charging, okay, the electrochemical cell is now an electrolytic cell. Now, what are electrolytic cells? Electrical energy is bringing about a chemical reaction. Okay, so what is happening when you are doing charging? You are supplying electrical energy and it is getting converted to chemical energy. Okay, the batteries which we are using, like the lithium ion batteries and all, are nothing but reversible cells, okay, or secondary cells, okay, in which the cell reaction is reversible. That we'll talk a little later. For our convenience, we'll just put the discussion here to the point that electrochemical cells are, when we are talking in an abstract way, and if I just give you the definition, electrochemical cell ante ఎక్కడైతే కెమికల్ రియాక్షన్స్ అయ్యి ఎలక్ట్రికల్ ఎనర్జీ వస్తుందో లేదా ఎలక్ట్రికల్ ఎనర్జీ కెమికల్ రియాక్షన్ అవుతుందో అవన్నీ ఎలక్ట్రోకెమికల్ సెల్స్ అని అబ్స్ట్రాక్ట్ గా ఆలోచించామనుకో అంటే అదేదో సంథింగ్ ఓహో అన్నట్టు అనిపిస్తుంది. మన మొబైల్ బ్యాటరీ ఎగ్జాంపుల్ తీసుకుంటే అదే ఎలక్ట్రోకెమికల్ సెల్. సో ఎప్పుడన్నా నువ్వు ఒక సెల్ అని అంటున్నావు అనుకో, ఇట్ ఇస్ ఎ కాంబినేషన్ ఆఫ్ అన్ యానోడ్ అండ్ క్యాథోడ్. ఓకే, సో that's a major idea. సో నేను చెప్పాను కదా, ఎలక్ట్రోకెమిస్ట్రీ టాపిక్ లో మనము ఎలక్ట్రోలైటిక్ ఆర్ అయోనిక్ కండక్టెన్స్ గురించి మాట్లాడతామని. అంటే ఈ టాపిక్ లో 2 ఇంటర్ కన్వర్షన్ ఆఫ్ ఎనర్జీస్ ఎప్పుడు ఆలోచిస్తూ ఉంటాం. ఎలాగైతే కెమికల్ రియాక్షన్ ఎలక్ట్రికల్ ఎనర్జీ ఇస్తుంది, ఎలక్ట్రికల్ ఎనర్జీ కెమికల్ రియాక్షన్ ఎలా బ్రింగ్ అబౌట్ చేస్తుందో అలాగా మనము ఈ చాప్టర్ ని డిస్కస్ చేస్తూ ఉంటాం. ఓకే, ఎవ్రీథింగ్ హ్యాస్ అన్ అప్లికేషన్, huge industrial application. It is perfectly engineering oriented. Okay, so is the discussion. So yesterday we were talking about the construction of an electrochemical cell, where I have told you that the major important things to be mandatorily present in an electrochemical cell is an electrolyte, okay, and electrodes, wires for connectivity, and of course an insulating material which holds all these contents. Okay, are the 4 major ones that are very, very important for us. Okay, I think most of you would be handling the battery of our mobiles and all. When you just open the backdrop of this, we can see the mobile batteries and all. We just handle them. The outer sheathing is, of course, the insulating material in which the whole setup is there. Okay, and we'll talk about this lithium-ion batteries in the batteries topic. Okay, yesterday I was just talking to you about what are electrolytes, okay? Because they are the primary requisites for electrolytic or ionic conductance. Electrolytes are solutions which contain ions and conduct current. Okay. What is very important is that the electrolytes should have good number of ions for better conductance. Okay, because ions are charge carriers in electrolytic conductance. And then we move to the further description about the electrolytes into strong electrolytes and weak electrolytes. Strong electrolytes are solutions or electrolytes which have more number of ions because the solute in them is perfectly ionized or completely ionized and hence more current conductance. Obviously, if the solution has more number of ions, it conducts more current. And when the solution will have more number of ions, if its concentration is more or the solute is completely ionized or dissociated. Okay. Then we talked about the weak electrolytes. Weak electrolytes are the solutions which conduct less current. They conduct less current because they contain less number of ions. Why they contain less number of ions? Because the solute that is present in the solution is partially or incompletely ionized and hence is partial or weak electrolyte. Okay. And is the discussion. Fine. Anything else that I discussed yesterday about the electrolytes? Or did we stop there or anything else that I have discussed?
That's all.
That's all. Nothing else I've discussed about the electrolytes. Okay. Then I have a point with you all. Electrolytes will undergo decomposition or not? Did you understand my point? Did you understand my question? Will electrolytes decompose? Yes or no?
Yes, ma'am.
Okay. So this is what I think I told you all in Japan. Electrolytic conductance leads to dissociation or dissociation or decomposition of the electrolyte. Unlike the metallic or electronic conductance, in which, see, the copper wires which we are doing the electrical wiring for our houses, completely they are benign. Correct? Hankada. So electronic conductance will not degrade the material, but electrolytic conductance will result in degradation of the material. Okay, so that's another point I think you should write. So next dot point is, this is the 11th point. Under electrolyte, please do write. In Rastaru, electrolytes undergo dissociation or decomposition during conductance. Okay, what did you write? Electrolytes undergo dissociation or decomposition during conductance process. Okay, did you write that?
Madam, once again.
Electrolytes undergo decomposition or dissociation during ionic conductance. Okay. Hello. Did you ever listen about primary cells?
Yes, ma'am. Yes, ma'am.
What are they? What are they?
Non-rechargeable battery.
Which contain only one electrode.
No, one electrode ఉండదు ఎప్పుడు రెండు ఉండాలి సెల్ అంటే ఎప్పుడు రెండు ఎలక్ట్రోడ్స్
Not rechargeable.
Primary batteries లో సింగిల్ ఎలక్ట్రోడ్
Cannot be recharged.
అంటే
Use and throw
ప్రైమరీ బ్యాటరీస్ లో ఓన్లీ సింగిల్ ఎలక్ట్రోడ్ ఉంటుంది కదా మ్యామ్.
What? Sorry?
In cells, battery cell, one electrode ఉంటుంది.
One electrode undadu.
Which
One
cannot be
electrode
recharged.
Less lifetime.
non-rechargeable. Less lifetime, non-rechargeable. Why? Nowadays, did you see that this like charging plugs are there where we can just put in the battery, like our remote batteries or calling bell batteries and all. We are just plugging in and just plugging them, and they are undergoing recharging. Such a thing is there nowadays, correct?
Yes, ma'am.
Are
Yes,
you
ma'am.
using them? Yes, not all, but many. Many will throw them away. But nowadays we have like just this plugins in which I can just stuck in the two batteries and put it for charging. Correct?
Yes, ma'am.
So what might be the difference between that use and throw batteries and our mobile laptop batteries? What might be the major difference? What's happening?
Rechargeable.
Rechargeable
Electrolyte.
again.
Converting in
Electrolyte and
electrical
battery.
energy.
అదే అడుగుతున్నాను ఏంటి what is the deal in
Galvanic.
them?
Galvanic and
Only
electrolyte.
chemical energy converts to electrical energy in those.
అదే అమ్మా అన్ని galvanic cells ఎప్పుడైతే whenever there is an
It only
electrochemical
undergoes chemical
నార్మల్
energy into
సెల్స్ లో
chemical
అయితే
energy.
ఓన్ly వన్
cell
Electrolyte,
reaction.
ma'am.
See, electrolyte is there in any, that is what I'm trying to give a clear picture to you all. Okay, and remember, whenever I utter that word electrochemical cell, what it has one electrolyte. That electrolyte undergoes decomposition compulsorily. Okay, and it is also having electrodes. A combination of an anode and cathode is called as a cell. When I use that word cell, it means that it has two electrodes. One is anode, the other one is cathode. Okay, so a combination of an anode and a cathode is nothing but a cell. And a battery is a combination of such cells to give the net output. Okay, but then when the discussion is all about the rechargeability of the batteries, which is application of the electrochemical cell. So I just told you that electrolytes compulsorily undergo dissociation, and the ions that are formed due to the dissociation of the electrodes will move to the oppositely charged electrodes, and hence is the current conductance. It means that's a concept. Now, what we need to understand here is that the electrolyte does undergo decomposition, okay, when it is acting as a galvanic cell or a voltaic cell. But if you're providing a charge little more than its EMF, then it is resetting the cell reaction in such a way that the reactants are formed back again, and hence the batteries have become rechargeable. So ante reversible reaction అవుతుంది. ఆ సెల్ రియాక్షన్ రివర్సిబుల్. రియాక్టెంట్స్ ప్రోడక్ట్స్ ని ఇస్తున్నాయి. ఆ రియాక్టెంట్స్ ప్రోడక్ట్స్ ని ఇచ్చేటప్పుడు ఏమవుతుంది, అది గాల్వానిక్ సెల్ కింద యాక్ట్ చేస్తుంది. సరే, ఆ దాంట్లో ఒకటి యానోడ్ ఉంటుంది, ఒకటి క్యాథోడ్ ఉంటుంది. సరే, ఆ యానోడ్ కి క్యాథోడ్ కి మధ్య ఉండే పొటెన్షియల్ డిఫరెన్స్ ఈఎంఎఫ్ ఆఫ్ ద సెల్. ఆ బ్యాటరీ ఎంత 2 వోల్ట్ బ్యాటరీ, 3 వోల్ట్ బ్యాటరీ, 12 వోల్ట్ బ్యాటరీ అంటాం. అంటే మీనింగ్ ఏంటి? ద పొటెన్షియల్ డిఫరెన్స్ బిట్వీన్ దట్ యానోడ్ అండ్ cathode is what we are saying actually in a layman's language. But technically, there's an anode and cathode which are having a potential difference of so many volts. Okay. And during this process, what will happen? The chemical reaction is taking place. There is decomposition of the material and it is giving products. Okay. And it is acting as galvanic or voltaic cell. Okay. If you are providing energy little more than the energy during discharging, then if the cell reaction is reversible, the reverse reaction is taking place. The products are acting as the reactants now, and they are giving back the reactants once again. How much you should supply? Little more than its EMF. Okay, if you are taking a 2-volt battery, more than 2 volts, around 2.2 or 2.5 volts max, if you can supply, a reverse reaction is taking place. And when the reverse reaction is taking place, it is acting as an electrolytic cell. And hence the batteries are becoming rechargeable. Now, if the cell reaction is irreversible cell reaction, in such a case, we have to use the battery and throw it. That's it. Okay. And such batteries, though they are less expensive, are not nowadays finding their way. Okay. So even the mobile or whatever the batteries, ever-ready batteries, or sort of a battery fabrication only is changing. Okay. So it's the discussion. So what you should understand here is that after the decomposition, once if the cell reaction is possible in a reverse direction, then the reactants are gained back and the battery can be used through several cycles of charging and discharge. Okay, అది point అన్నమాట ఇక్కడ మనం తెలుసుకోవాల్సింది. Correct? So that's about the electrolyte. Okay, so right, the next one. See, actually all these things you are knowing it very clearly, but the main idea here is, let me put these basic points in your notebook. Okay, rest all we have notes, and I can just mail you notes and you can just study. But these basic things are something which you need to understand with a lot of clarity before we move into the discussion of the main topic. Okay, so that's the reason why I'm asking you again and again to write notes, and these are all viva voce questions for your lab exams. So is the importance. You should write them. I insist. Okay. So the next one is electrodes. Right. Electrodes. Then I've told you the next one, which is very important for the construction, is an electrode. So what are electrodes? Right. These are the medium. These are the medium through which electrons enter and leave the electrochemical cell. These are the medium through which electrons enter and leave the electrochemical cell. You know it, but that's the way you have to put it. Okay. Next point. They can be rods. They can be rods. Thin films. Thin films.
What is that, ma'am?
Thin films. Thin films or plates. Thin films or plates that's a fabrication part. Okay, full stop. Now under electrodes, I think this is the third point. What you need to know is electrodes. I'll just I need to show you again a small flow chart. Yesterday I've already told you that the electrodes can participate in electrochemical reactions. Like you might have studied about various extractions during your intermediate in metallurgy and all, where the pure metal is taken at cathode, and the impure material is taken at anode, and during the electrolysis process, the pure metal gets deposited on
the cathode, leaving anodic mud at anode. Okay. What is very important is that the coat material at cathode should be one of the major constituents of the electrolytic solution. Okay. So in this case, what is happening? The electrode is participating in the electrochemical reaction. Okay. Such electrodes are called as attackable electrodes or active electrodes. Okay. That means in this case, the electrode is participating in the electrochemical reaction. Okay. Because it is participating, you want to tell that the electrodes are participating in the electrochemical reactions. Such electrodes, you'd say them as active electrodes or attackable electrodes. One, again, what you have in your syllabus is the lead acid batteries. You know it? Lead acid batteries. Many of us, we know that car batteries, 12-volt car batteries we'll be using at home. And what we know is that um, we'll add water to the battery. Why? All that we'll study. And it's a secondary cell. In this case, the electrodes are attackable. That means the lead and lead oxide plates that are present in the battery are participating actively in the chemical reaction. Okay, and hence active electrodes. Whereas there is another set of classification of electrodes into non-attackable or inert electrodes. The best example is our lithium-ion batteries. In lithium-ion batteries, we take graphite rods as anode and cathode, and none of the electrodes will participate in the chemical reaction, and hence the electrodes are remaining neutral for the chemical reaction, and hence are called inert or non-attackable electrodes. That is one of the classification. Okay. What's the other classification of electrodes is that they are the type of chemical reaction. Okay. If oxidation reaction is taking place, the electrode is called as anode. When reduction is taking place at a particular electrode, the electrode is called as cathode. No matter what is the sign of these electrodes in the electrochemical cell. Okay, so that's the classification of electrochemical cells. Adhamain kada? Okay, so what you'll write? What you'll write? Right. I'll just turn the camera and this time write. Electrodes. Now my discussion is about electrodes. So write electrodes in a block at the center of the page. Okay. And there are two classifications of electrodes. The first one is active or attackable electrodes. Active or attackable electrodes. Active or attackable electrodes. The other set is inert or passive or non-attackable electrodes. Inert, passive or non-attackable electrodes. That's one set of classification. Okay. What is the other set of classification? See, don't focus. I'll help you out. I think you should. You can write. That's what I need to say. You can catch it. active or attackable, inert or passive or non-attackable electrodes. The other set of classification in Chapandi. Huh? The other set of classification ఏంటి? Hello kids, now this is brief. Huh? ఇంకో classification ఏంటి నాన్న?
Anode cathode.
Yes, good. The other classification of electrodes is into two types, anode and cathode. ఇది మీకు బాగా క్లారిటీ ఉండాలి. This you should have lot of clarity to play with your subject. See, మీకు తెలుసా? Once you understand all these things, the rest all will just keep flowing in your head. Anode, or it is oxidative electrode. Anode or oxidative electrode. Anode or oxidative electrode. Cathode or reductive electrode. Cathode or reductive electrode. Anode or oxidative electrode, cathode or reductive electrode. Easy? So would you like to write the 2 points there? Okay, right. Active electrode. Active electrode. Active electrode. Active or attackable electrode ante enti? Cheppandi. Come on, buck up.
Which
What
participate
is active electrode? Huh?
which participate in
The electrochemical reaction. Huh? Right. Electrode which participates in electrochemical reaction. The electrode which participates in electrochemical reaction. Example.
Platinum.
Electrodes in lead acid battery cell. Electrodes in lead acid battery cell. Electrodes in lead acid battery cell. Okay. Now roll number 69. Absent?
Yes, ma'am.
Okay. Tell me example of inert electrode or passive electrode. Roll number 69.
Ma'am, inert gas or passive electrode, ma'am?
Amma? Example చెప్పానా? Passive electrode example చెప్పానా లేదా నీకు?
Helium, argon.
Lithium.
Helium electrodes.
In lithium ion battery. Right? Inert or passive electrodes. Inert or passive electrodes. Electrodes do not participate in electrochemical reaction. Inert or passive electrode. Electrodes do not participate in the electrochemical reaction. Example, graphite rods in lithium ion battery. Dark 116. Dark. Sidhu,
yes ma'am. Hello, yes ma'am.
lithium ion battery has which type of electrodes? Cheppu Sidhu. Lithium ion battery has which type of electrodes? Cheppu. Huh?
Hello, ma'am.
Inert or
Hello.
passive?
I can't hear you, ma'am.
No.
Hello.
Huh?
Hello, ma'am.
Tell me, Sidhu.
Hello.
Modhu.
Hello, ma'am. I can't hear you, ma'am.
Why? Why you can't hear me?
Hello.
Okay. Mute yourself. Listen to this at least properly. Mute.
Hello.
Smart boy. Okay. Next. Chepana? Smart boy and smart technologies everywhere around. Okay. I'll get back. Next. Anode. Anode. The electrode at which oxidation takes place. The electrode at which oxidation takes place. In brackets, loss of electrons. Loss of electrons. You can write oxidation is equal to loss of electrons. Oxidation is equal to loss of electrons. Okay. Next, cathode. The electrode at which reduction takes place. The electrode at which reduction takes place. The electrode at which reduction takes place. Reduction is equal to gain of electrons. Reduction is equal to gain of electrons. I want to share one thing with you all. In the beginning of my career, particularly when I joined the MBSR college, ECE was the first batch, of course. The alumni still are very close to me. And what a class it would be. That's a sad thing that I'm not able to interact with you all in person. It was very fantastic. Probably as an young teacher myself, and students also were very strong and very intelligent. If a word thrown out from my mouth, they would just catch like a magnet. Sometimes the class used to be very interactive, very interactive. In fact, now that's not possible here on this, through this online education. And any small naughty actions, by chance they would speak or do something, I used to be very tough as well. Make them stand and ask as many questions as possible. And to my surprise, it always would be like they would answer all the ones. Okay, so few kids had such such an attitude that they want to answer any question or they want to face the viva from the teacher. They would deliberately talk to make me angry, and then I would pour out all my questions and all things on their heads till they would stand the test of the faculty. The passion with which they would do, or the entire class, nearly all 40% of out of 60, I would say more than 50 students would just puzzle so much that they are always in the class. They always used to have that zeal. Yeah, they're very friendly, they're very good, they're very interactive, everything is fine about them. But when it comes to learning and all, they used to be very competitive and very healthy competition, I would say. That spirit somehow is now diluted It's not that you are less competent, but the spirit is diluted. That's a small thing which I'd like to say. But that's a culture you should develop. Be positively competitive. It will really bring out best things in you all. Okay? What you should always focus is on the learning methods. How I can learn a new subject. Why I'm saying you this is, initially when all these things are easy and you're able to understand, you'll enjoy the class. Down the lane, the attendance keeps on decreasing. And I just wonder why the attendance would decrease. It's because many would find it difficult to learn new things. And that's what is a skill you need to really develop. Okay, new topic is given also. By chance, if you're not able to understand also, keep that spirit that if not once, you'd study again and get the point clearly in your head. That should be your spirit. Okay, we'll get back. Hope you have written all the points there. Okay. So, it's the discussion. Anode is oxidation electrode, where there is loss of electrons. Cathode is a reduction electrode, where there is always gain of electrons. Now, I'll ask you an important question. What is the sign of anode and cathode? This is a common
Anode
thing.
negative, cathode positive.
Anode negative, cathode positive.
Anode positive,
Anode
cathode
positive,
negative.
cathode negative.
What is this?
Anode positive, ma'am.
Anode positive.
Anode positive.
Negative, anode
Yes,
negative.
ma'am. Anode.
Should
Anode
be
positive.
right answer. Yeah. I go on the
Anode negative, ma'am.
Anode positive, cathode
Anode
negative.
positive.
Anode positive.
Anode positive.
Ma'am,
I go on
anion
the
goes
I
to
go on the
anode, cation goes to cathode.
huh? Kadu.
At anode, electron loses, so positive charge.
Anode negative, ma'am. Cathode positive.
This is the reason why I'm asking you to write these things on the paper. Because these are things already you have studied long back, but you'll not find it in the notes which are there for your syllabus, in fact. But these are important, very important. Both the answers are correct. But when?
If battery positive terminal is connected to anode, then it is negatively charged, ma'am. If negative is connected to anode, then it is positive.
Okay, I'll tell you. I'll do the job for you. Keep the clarity now. The sign of anode and cathode depends upon the type of electrochemical cell. If the electrochemical cell is electrolytic cell, okay, then anode is positive, cathode is negative. Okay. No. If the cell or battery, if the cell is galvanic or voltaic cell, then anode is negative, cathode is positive. Okay. So these are the signs of anode and cathode, and it depends upon the type of electrochemical cell. So both the answers are correct. But when anode is positive and cathode is negative, in the case of electrolytic cell, and in the case of galvanic or voltaic cell, anode is negative, cathode is positive. Understood? And hence should be written very clearly. But what you should remember is that in both the cases, at anode there is always oxidation, and at cathode there is reduction. Ella, you remember. You say, for example, NaCl solution is there, okay, and you are doing electrolysis reaction. That means you have connected them to a battery, for example. Emotunde, to anode, because it is positively charged, the negative ions go. Okay, the negative ions go and lose their electrons. So oxidation. At cathode, the positively charged ions would go, gain electrons, and hence reduction. Okay. So at anode, oxidation, cathode, reduction. I'll come back to galvanic or voltaic cells. In galvanic or voltaic cells, what will happen? The electrode at which there is loss of electrons is always taken as anode by default. That is IUPAC nomenclature. The electrode at which there is gain of electrons is taken as cathode and it is given a positive sign. And by default, hope you know how to represent a battery. How will you write a battery? There is a longer line and there is a thin longer line and thick shorter line. Okay. The thin longer line is called
Positive terminal.
positive. The thin shorter line is called cathode. Okay. Negative terminal. Okay. And so is the convention of IUPAC. Always anode is taken on the left hand side and cathode is taken on the right hand side. Anode left, cathode right. That's a standard one. Okay. But the sign of anode and cathode might be different. When there is positive, when there is positive sign, in the case of electrolytic cell, anode is positive, cathode is negative. Whereas in a galvanic or voltaic cell, anode has negative sign because it is at that place electrons are given, and cathode it is a positive sign because electrons are taken. Okay, and hence is the discussion. Did you understand or do you have any doubts? If you have a doubt, please raise your hand.
Ma'am, please once and tell ma'am why positive, negative, anode and cathode in electrolytic cell, ma'am.
Chudo. Electrolytic cell. You first tell me in electrolytic cell, what is the reaction happening? Which energy is getting converted to which energy? Tell me, boy. In an electrolytic cell, which energy gets converted to which
Electrical
energy?
energy to chemical energy.
Electrical energy is converted to chemical energy. అంతవరకు అర్థమైంది సరే సో మీకు ఈజీగా అండర్స్టాండ్ అవ్వడానికి I'll just this example. Our famous example is take a electrolytic cell. Okay, what I told you, whenever I tell cell, it is anode and cathode. So there is there are two rods I have kept in, and there is electrolyte. Okay, I think I am pressing this. Okay, and I am connecting this to a battery. Okay, fine. So I am supplying electrical energy to the system with the help of a battery. Okay, in a battery, the thin line is the thin longer line is positive terminal and the thick shorter line is negative terminal. Okay, now this is positively charged terminal and this is negatively charged terminal. Okay, now I have taken a solution, for example, HCl. That is easy for me to explain. Okay, now HCl will dissociate to form H plus ions and Cl minus ions. Okay, so this is an aqueous solution. Now, where would the Cl minus ions move? It would slowly move towards the positive terminal. Okay, and where would this H plus ions move? It would slowly move to the negative terminal because the unlike charges would attract. Now I'll talk about the movement of Cl minus ions towards the anode. Positive. minus will give away its electrons to get released as Cl2 gas. Okay. What is Cl minus ion doing? It is moving towards the electrode and it is giving away its electrons and it is getting released as Cl2. Now, what is loss of electrons called? Oxidation. So, the electrode at which oxidation is taking place is called as anode. Now, what will happen to H plus ions that are present? These H plus ions slowly move towards this negative electrode and they take electrons from the electrode, get reduced to hydrogen gas. Okay. Because electrons are taken, gain of electrons is called as reduction. At this negative terminal, okay, there is gain of electrons. The electrode at which gain of electrons is taking place is called as cathode, and the electrode at which loss of electrons is taking place is called as anode. అర్థమైందా? అంటే ఏం చెప్పాను? ఎక్కడ ఆక్సిడేషన్ అవుతుందో ఆ ఎలక్ట్రోడ్ ని యానోడ్ అంటా, ఎక్కడ రిడక్షన్ అవుతుందో ఆ ఎలక్ట్రోడ్ ని నేను క్యాథోడ్ అంటా. అంతే, అది కన్వెన్షన్. దాని సైన్ ఇర్రెలెవెంట్. సరే, అయితే ఇప్పుడు ఒక డౌట్ వచ్చింది. యానోడ్ క్యాథోడ్ ఏంటి సైన్ మారిపోతుంది అంటే సైన్ గురించి పట్టించుకోవద్దు. ఫస్ట్ ఐయుపిఎస్సి కన్వెన్షన్ గురించి ఆలోచించాలి. ఏం చెప్తారు ఐయుపిఎస్సి కన్వెన్షన్ లో? ఏ ఎలక్ట్రోడ్ దగ్గర అయితే లాస్ ఆఫ్ ఎలక్ట్రాన్స్ అవుతుందో అంటే ఆక్సిడేషన్ అవుతుందో అది యానోడ్. ఏ ఎలక్ట్రోడ్ దగ్గర గెయిన్ ఆఫ్ ఎలక్ట్రాన్స్ అవుతుందో అది క్యాథోడ్, అంటే రిడక్షన్ అవుతుంది ఆ ఎలక్ట్రోడ్ దగ్గర. సరే, ఇప్పుడు రెండు ఎలక్ట్రోడ్స్ ఉన్నాయి. ఆ రెండు ఎలక్ట్రోడ్స్ నేను రెండు టెర్మినల్స్ ఆఫ్ ద బ్యాటరీకి కనెక్ట్ చేశాను. ఓకే, నా సొల్యూషన్ లో రెండు అయాన్స్ ఉన్నాయి, H ప్లస్ అయాన్స్, Cl మైనస్ అయాన్స్. ఓకే, ఏమవుతుంది? నెగిటివ్ అయాన్ కాబట్టి అది పాజిటివ్ ఎలక్ట్రోడ్ దగ్గర మూవ్ అవుతుంది. మూవ్ అయ్యింది, ఎలక్ట్రాన్స్ ఇచ్చేసింది, లాస్ ఆఫ్ ఎలక్ట్రాన్స్ ఇస్ కాల్డ్ ఆక్సిడేషన్, Cl2 గ్యాస్ రిలీజ్ అయింది. అదే H ప్లస్ అయాన్స్ ఉన్నాయి, అది పాజిటివ్లీ చార్జ్డ్ అయాన్స్, సో నెగిటివ్ టెర్మినల్ దగ్గరికి మూవ్ అయ్యాయి. అదే నెగిటివ్ టెర్మినల్ కి మూవ్ అయితే అక్కడ ఏమవుతుంది? ఎలక్ట్రాన్స్ ఎక్సెస్ ఉంటాయి, ఎలక్ట్రాన్స్ తీసుకుని H2 గ్యాస్ రిలీజ్ అయింది. ఇక్కడ గెయిన్ ఆఫ్ ఎలక్ట్రాన్స్ కాబట్టి రిడక్షన్, సో క్యాథోడ్. ఇక్కడ లాస్ ఆఫ్ ఎలక్ట్రాన్స్ కాబట్టి ఆక్సిడేషన్, సో ఇట్ ఈస్ యానోడ్. సో నువ్వు ఎలక్ట్రోడ్స్ డిఫైన్ చేసేటప్పుడు సైన్ ఆఫ్ ఎలక్ట్రాన్ ని బట్టి యానోడా క్యాథోడా అని డిఫైన్ చేయట్లేదు. ఎప్పుడు ఎలా డిఫైన్ చేస్తున్నావు? యానోడ్ దగ్గర ఎక్కడ ఎలక్ట్రోడ్ దగ్గర ఆక్సిడేషన్ అవుతుందో అది యానోడ్ అంటున్నావు, ఏ ఎలక్ట్రోడ్ దగ్గర రిడక్షన్ అవుతుందో అది క్యాథోడ్ అంటున్నావు. అర్థమైందా? ఆ సైన్ డిఫర్ అవుతుంది. ఎలక్ట్రోలైటిక్ సెల్ లో అది పాజిటివ్, అదే ఎలక్ట్రోకెమికల్ సెల్ లో అది నెగటివ్, అదే వైస్ వర్సా విత్ క్యాథోడ్. సో ద ఎలక్ట్రోడ్స్ are defined on the basis of the electron gain or loss, that is whether oxidation or reduction is taking place or not on the sign. Okay, you understood? Understood, boy? Charana, Chandra, you understood? What's your doubt? Okay, and hence is the discussion. So can I write one chart? Okay, what I'll do, I'll put a bigger square like this. Okay, then I'll make it into three columns. One is anode, the other one is cathode. Okay, and this is cell. Okay, then what I do in electrolytic cell, anode is positive, cathode is negative. Whereas in galvanic or voltaic cell, anode is negative, cathode is positive. That's it. But what is constant here? Anode oxidation, cathode reduction. Okay. Anode oxidation, cathode reduction. That's a thumb rule. Fine. So, the discussion. Roll number 70. There.
Yes, madam.
Good morning. Roll number 70.
Yes, madam.
Roll number 70 is absent today.
Present, ma'am.
Okay, Kirti. This is Kirti. What's roll number 70? Please tell me your name. Hi.
I'm K. Harshita.
Harshita. Harshita. At anode, what reaction takes place?
Oxidation reaction takes place, ma'am.
Oxidation is loss of electrons or gain of electrons?
Loss of electrons.
What reaction takes place at cathode?
Reduction reaction.
Gain of electrons or loss of electrons?
Gain of electrons.
What is the IUPAC convention?
Anode is always at anode always oxidation reaction takes place, and at cathode always reduction reaction takes place.
On which side anode should be present?
On left side, ma'am.
Yes, that's it. On the left hand side, there is always anode. On right hand side,
it's always cathode.
Cathode. What it means by cell?
Cell. Cell where chemical electrochemical reaction takes place.
There. Okay. Well, the electrochemical reaction, and it is always a combination of an anode and a cathode. So, what it means by a cell? A combination of an anode and a cathode. Okay. Now, Harshita, I have a question to ask, and I think this is a physics question, which I want to once again get clarity. What it means by a diode?
Diode is a semiconductor where P and N junction, P-type electrode and N-type electrode are connected.
Okay, Harshita. Thank you, but it was good. Good. Okay, Harshita. Now, anyone in the class, what it means by a diode?
Which only allows current in one direction, madam. Which only allows current in one direction.
Which allows current only in one direction is called a diode. What it means by combination of an anode and cathode called in physics? Check it. Okay, but I'll just tell you. As far as electrolytic conductance is concerned, a cell is always a combination of an anode and a cathode. Okay, where anode is on left hand side and cathode is on the right hand side by convention. Okay, write this point. Right. A cell is a combination of an anode and a cathode. A cell is a combination of an anode and a cathode. A cell is a combination of an anode and a cathode. Cathode full stop. Under standard convention, anode is on left hand side and cathode is on right hand side. By standard convention, anode is on left hand side and cathode is on right hand side. Node is on left hand side and cathode is on right hand side. Okay. So we spoke about the electrolyte and the electrodes. Fine. Then of course the next point. This is point number 15. What's the point number? Always write it in as points, kids. If not, it will be damn boring. And it's easy to memorize if you put it as a point. Okay, so what's the point? 15th one or 16th?
16 ma'am.
16. Okay, 16th point ఏంటంటే right. The electrodes are connected externally with the help of wires. The electrodes are connected externally with the help of wires for the flow of electrons. For the flow of electrons. Roll number 80. Roll number 80.
Ma'am.
What's your name?
Pragna, ma'am.
Huh?
Pragna.
Prerna. Hi, Prerna.
Ma'am, Pragna.
Sorry, didn't get you.
I'm Pragna, ma'am. Pragna.
Pragna. Pragna, now tell me. I've connected the electrodes with the help of wires. If it is a electrolytic cell,
Ma'am.
you get my point? If it
Yes,
is an
ma'am.
electrolytic cell, I need to connect them to what? The two wires. Pragna.
What? I didn't get you, ma'am.
See, now I've constructed my electrochemical cell. So I've given you what are the 4 basic important things that are to be taken into consideration. The setup should be taken in a insulating material. Then I'll take the electrolyte. Then I'll take the electrodes, and I'll connect the electrodes, both the electrodes, anode and cathode. I have to complete the circuit, is it not? So I've connected anode and cathode with the help of wires. The wires will help in electron flow. Okay. Now tell me, there is electrolytic cell. So what are electrolytic cells, Pragna?
Which convert electrical energy into chemical energy.
Exactly. Good. So electrical energy is converted to chemical energy. So which energy you are supplying?
Electrical energy.
So you have to connect both these wires to what?
Anode and cathode, ma'am.
Deni connect chestavu?
Positive terminal.
Positive terminal and negative terminal of
anode and cathode.
Deniki? Battery?
Yes, ma'am.
No?
Yes.
Connected to a battery.
Ma'am.
What it means? AC power supply, DC power supply.
Ma'am?
What it means by AC power supply and DC power supply?
In DC power supply, there is a constant flow of current, but in AC power supply, there is no constant flow of current, ma'am.
Constant flow లేకపోతే ఎలాగా మనం అన్ని ఫ్లికర్ అవుతాయి కదా. But the answer is correct. So the two wires in an electrolytic cell are connected to a power supply. I will write like this. Okay. So the two wires in an electrolytic cell are connected to A battery or external power supply. Battery is DC power supply source and AC power supply is our regular supply. Now, anyone in the class, can you tell me clearly what it means by AC power supply and DC power supply?
Current does not change with time, ma'am. Here current changes with the time and positive and negative cycle.
The direction of flow of current
Current
changes
changes.
with time
Magnitude
in
and
AC.
direction of current changes.
Direction of current, huh?
Yes, ma'am. Direction also changes.
Direction of current changes. And the signal, charge, what does it mean?
Wave, alternating waveform.
Waveform. ఎందుకంటే I got this doubt again. అదేంటి నేను బ్యాటరీ ఛార్జింగ్ కి పెట్టినప్పుడు ఏం చెప్తున్నానంటే ఇఫ్ ఐఎమ్ కీపింగ్ మై బ్యాటరీ ఫర్ ఛార్జింగ్ then I'm passing obviously AC power supply kada. I'll plug it just.
Transformer will be there, ma'am. Transformer will convert.
Internal transformer would be there.
Adapter లోపల ఉంటుంది.
Adapter. Which will convert AC power supply into DC power supply.
Yes,
RLC,
ma'am, and it will.
That won't be
RLC
there.
circuit.
Amma, Nana?
RLC circuit, ma'am.
RNC circuit. Sure. So check.
Think so.
Think odu. Electronics world.
Rectifier.
But what my knowledge goes is that they will not supply DC current. Why? It leads to electrolysis. They'll always see to it that AC power supply is kept intact because we just want a chemical reaction to take place in the reverse direction. That's it. But I don't want any electrolysis of the products. Is it not? So they keep the AC power supply only. Otherwise, in our normal gadgets, depending upon the utility, they might put a converter, AC-DC power converters, they might put, but may not. This is not the case in the case of our batteries. Why? Because if you supply DC power supply only, then what will happen? There is possibility of charge polarization around the electrodes because of electrolysis. So that's the reason why it's only AC power supply all through. Understood? And then just with plug in. My idea is to just supply little energy more than its EMF so that the reaction proceeds in the reverse direction. That's it. That's my idea. I don't want any electrolysis to take place during the process and hence no charge polarization. Okay, so that's the concept. Okay.
Ma'am, once again explain what you have just said, ma'am.
Just listen to me. I was trying to tell you that the electrochemical cell is under consideration the battery. Okay, so the battery went discharging. Okay, so while discharging, depending upon the potential difference between anode and cathode, it had some EMF. That is what I am saying as 2-volt battery, 3-volt battery. It means what? The potential difference between anode and cathode. Okay, the chemical reaction kept on giving the products. And when the battery has underwent discharging completely, it means that one side of reaction is over. Now, because my mobile has underwent discharging, I just plugged in. Okay, and now I am saying I'm doing the charging of the battery. Okay, for doing the charging of the battery, what I am doing, I'm supplying external power supply. That is AC power supply, where the sign of the electrodes is not constant like DC power supply. What is happening? Why I am supplying AC power supply? Now what is happening? In the recharging, now the products are combining to form the reactants back. Okay, So as far as chemistry is concerned, the cell reaction is reversed. అంటే డిశ్చార్జింగ్ లో ఏవైతే ప్రొడక్ట్స్ ఫామ్ అయ్యాయో అవి ఇప్పుడు కంబైన్ అయ్యి రియాక్టెంట్స్ ని ఇస్తున్నాయి. వన్స్ అగైన్ దట్ ఈస్ ద చార్జింగ్ ప్రాసెస్ ఎగ్జాక్ట్లీ ఐఎమ్ డూయింగ్. ఓకే, ఇప్పుడు ఏం చేశాను, నేను ప్లగ్ ఇన్ చేశాను కదా, అప్పుడు ఎలక్ట్రోలైటిక్ సెల్ కదా, అంటే ఒకటి యానోడ్ ఒకటి క్యాథోడ్ కింద యాక్ట్ చేయాలి. ఓకే, but I don't keep the electrode sign constant because I supply AC power supply. ఇప్పుడు నేను కాన్స్టెంట్ ఉంచానే అనుకో, అప్పుడు ఏమవుతుంది, along with the products combining to form the reactants, there is one more side effect that might take place, electrolysis. Okay, which I don't want to happen. If electrolysis is taking place, what will happen? There is charge polarization and accumulation of charge in the electrodes అవుతుంది, which I don't want to happen. అది అవాయిడ్ చేయడానికి ఏం చేస్తానంటే నేను ఏసీ పవర్ సప్లై పాస్ చేస్తాను. ఎందుకు అంటే నా టార్గెట్ ఎలక్ట్రాలిసిస్ చేయడం కాదు. ఎనర్జీ కొంచెం ఎక్కువ సప్లై చేస్తే ఏమవుతుంది, రియాక్టెంట్స్ కంబైన్ అయ్యి ప్రోడక్ట్స్ ఏవైతే ఫామ్ అయ్యాయో రియాక్టెంట్స్ ఫామ్ చేయడం, అంటే సెల్ రియాక్షన్ ని రివర్స్ చేయడమే నా టార్గెట్. నా టార్గెట్ ఏమి ఎలక్ట్రాలిసిస్ చేయడం కాదు. కాబట్టి నేను ఐ స్టిక్ టు ఓన్లీ సప్లై ఆఫ్ ఏసీ పవర్ సప్లై. అర్థమైందా? డీసీ పవర్ సప్లై చేయను. ఎందుకు అంటే డీసీ పవర్ సప్లై చేసి కాన్స్టెంట్ ఎలక్ట్రోడ్ సైన్ పెట్టాను అనుకో, అప్పుడు ఏమవుతుంది, అయితే ఎలక్ట్రోలిసిస్ కూడా అవుతుంది. అలాంగ్ విత్ ద రియాక్టెంట్స్ being formed, there is one more side reaction, that is electrolysis, which leads to accumulation of charge around the electrodes, which I don't want to happen. So అందుకనే AC power supply tuckman plug in చేసి పెట్టేస్తాం. That's the idea. Okay, but I'll conclude the introduction today. So in AC power supply, in electrochemical cells, okay, if the cell is electrolytic cell, the anode and cathode are connected with the wires to a DC power supply. Okay, and in the case of an galvanic or voltaic cell, they are connected to a potentiometer or a galvanometer to know the direction of the current or flow of amount of charge that is flowing, and hence is an electrochemical cell description. Okay, you understood? So that is the introduction to the electrochemical cells. Types of electrochemical cells are galvanic voltaic cells or electrolytic cells, depending upon the type of chemical reaction that is taking place. Okay, and I think what's the time? 12:18. For 1 minute, I'll take the attendance. And today many are absent. I think they are not enjoying the session. I should improve on it. Okay, now just answer your roll calls quickly. You have, I think, which is the next period?
PPS, ma'am.
PPSO. Okay, you should I think go. As soon as you answer your roll call, please log out and you can just join your next class. Roll number 61.
Present, ma'am.